Hi everybody, Mrs. Bowen here. We're going to take a look at Learning Target 2.3. I can graph and solve one variable inequalities. So we're no longer dealing with equations, we now have inequalities. So in place of the equal sign, there are actually 4 different inequality signs that we're going to write down. So the first type of inequality sign is this, and it is called greater than sign. And then this is the less than inequality sign. So greater than and less than. And then we also have greater than or equal to. So it looks like the greater than sign, but there's a bar under it, or equal to. So this is greater than or equal to. And then same thing here, less than or equal to. So it's got the or equal to bar underneath it. So less than or equal to. So these are the 4 different inequality signs that we will now see in the place of the equal sign. Let's first talk about the greater than or less than sign. So you always read these from left to right. So just like you would reading across a page, as I read from left to right, this reads greater than and this reads less than. When we look to go put these on a graph here, we have number lines. We need to know what type of circle, and there are 2 different types of circles. So when we have greater than or less than, it is an open circle. So it is an open circle, and this means that whatever number that you put this open circle on your number line, it is not a solution. So I'm going to say number is not a solution. So we'll see what that looks like on a number line. Anything that would be greater than the number, but the number itself, where the open circle is not part of the solution set. Versus when you have the or equal to bar underneath your inequality sign, it is now a closed circle. So fill in your circle. It is now closed, and the number that the closed circle on is a solution. The number is a solution. So this is just a helpful way to visualize the 2 different inequality signs that have an open circle and the 2 different inequality signs that have a closed circle. And we'll see what it looks like now with some examples. So it says to draw a graph for each inequality. And for example 1, we read from left to right, and you always read from the variable. X is less than 3. So the first thing you need to do is find 3 on your number line. Now you need to decide, is it an open circle or a closed circle? Because we have no or equal to line under it, it's going to be an open circle at 3. And its x is less than. So anything less than 3 is a solution. So you need to draw an arrow going to the left for less than, meaning 2 is less than 3. That works. -5 is less than 3. So that works. And make sure you put an arrow because this continues on forever, right? -100 is less than 3, so that works. But 3 itself, there's a hole here. There's an open circle. 3 itself is not a solution. That does not work. So the solution here is anything less than 3. So 2.99 would be less than 3, so that would work. All right, example 2, n is greater than or equal to -5. So we need to go find -5 on the number line. Because we see the or equal to line, it needs to be a closed circle. So you need to fully shade in to make a closed circle. And it's greater than or equal to. So we took care of the or equal to part because we shaded it in. But now we need to make it be anything greater than -5. So we need to draw our line going above -5. -4 is greater than -5. 3 is greater than -5, etc. Example 3 looks a little bit different because it's starting with the number and not with x. I mentioned you always have to read starting from the variable. So if you were reading this, you would read it x less than or equal to 5. And I think that is confusing. I would rewrite this, x is less than or equal to 5. So all I did was write it so that it's basically I wrote it backwards, right? X less than or equal to 5. X less than or equal to 5. I find that when students do not rewrite it with the variable on the left, that you draw your arrow the wrong way. So this is what I want to use when I go to graph on my number line. So the number I'm looking at is 5. Find 5 on your number line. Because I have the or equal to bar means that it will be a closed circle. And it's anything less than it. So less than meaning going to the left. If you would have graphed based on the inequality that was given to you, the inequality statement here, this looks like a greater than or equal to sign. It is not, because you have to read it from the variable. So again, you're reading it backwards, x less than or equal to 5, which is why I always prefer to rewrite it here, x less than or equal to 5 with the variable on the left. All right, last example here. Again, I see my variables not on the left, so do not shade this as a less than on the number line. This reads p is greater than -2, so I'm going to prefer to rewrite it. P greater than -2. So find -2 on the number line. Because it's just greater than it, it does not include the -2. There's no or equal to bar. It's not equal to -2. It has to be greater than -2. So I need to put an open circle because there's a hole at -2. -2 is not part of the solution set. And now I need to shade everywhere where it's greater than -2. So greater than -2 would be going in this direction because 0 is greater than -2, 5 is greater than -2. Again, put your arrow. All right, so now you have 6 problems to try. Go ahead, pause the video, and then click play to check your answers. See how you did. On the first you try, you should have a closed circle at 4, shaded to the right. Second you try, you should have an open circle at 6, shaded to the left. When you get to you try 3, notice that the variable is on the right-hand side, so you have to read it from the variable. It reads m is less than or equal to 0. I, for the last 4 you tries, chose to rewrite them so that the variable is on the left. So for the third you try, you should have a closed circle at 0, shaded to the left. Fourth you try, you should have an open circle at -1, shaded to the right. Fifth you try, you should have an open circle at 7, shaded to the right. And for the last you try, you should have a closed circle at -3, shaded to the left. Now that you have an idea what these inequality statements look like on a number line, now we have to learn how to solve them. So we'll first solve them and then we'll put them on the number line just like we were doing. So it says solving inequalities is like solving equations, except there's a rule, a very key rule. So I put a star here. Make sure you emphasize this, that whenever we multiply or divide by a negative number, we must flip the inequality sign. So whenever we multiply or divide by a negative number, so that'd be like if we timesed by -8, or we times by -2, or we divide by -1, then we have to flip our inequality sign. Just like with equations, we had special cases. Here with inequalities, we have special cases. So if the inequality statement is true, then our solution is all real numbers. And an example of that would be if you get an inequality statement such as 2 is less than 5. That is true because 2 is less than 5, so your solution is all real numbers. If the inequality statement is false, then we have no solution. There's no solution that will make the inequality true. An example of that would be if you had an inequality statement such as 2 is less than 1. This is false. 2 is definitely not less than 1, so there would be no solution. All right, let's jump into some examples. So it says to solve each inequality and graph its solution. So you do have the number line here to graph, but that's the last thing we have to do. So first we have to find the solution. I'm going to rewrite these pretty small. So I have 20 less than or equal to 14 minus x. So I'm rewriting the long inequality statement, and now this is where I can solve it before I graph it. So I need to think back to all of the rules that we learned with solving equations, such as combining like terms on the same side, using inverse operations to move x's to one side and constants to one side. If you need a refresher on that, you could pull out your notes from solving equations because we will follow the same steps. So right here, I see that I have constants on both sides, and I'm trying to get this x by itself. So if I want to move constants to be on the same side, I need to move this positive 14. So I do that by subtracting 14 from both sides. Keep in mind, this is an equation, or just like with an equation, you have to keep it balanced. Let's see, let's zoom in here. So if I subtract 14 from one side, I have to subtract 14 from the other side as well. So on this side, I am left with negative x, and on the left-hand side, 20 minus 14 gives me 6. I almost have x by itself, but I need to get rid of this negative, or this negative 1. So I need to divide by negative 1. Ooh, what did I just do? Divided by a negative 1, right? Divide by negative 1. So I'm going to make a note here. I'm going to put a star, and I'm going to write flip. I have to remember to flip this inequality sign because I just divided by a negative 1. So on this side, I'm left with x, and on this side, 6 divided by negative 1 is negative 6. But I have to remember, flip the inequality sign. So it was less than or equal to. Now it's going to be greater than or equal to. So I'm going to circle these inequality signs here to add a little bit of emphasis to them that they flipped because we divided by the negative number right here. That's our rule. This is what I have to graph now. X is less than or equal to negative 6. I don't like seeing x on this side, so I prefer to rewrite it. That's just my preference. I'm going to rewrite it. X is greater than or equal to, x is less than or equal to negative 6. See, I almost did it again. X is less than or equal to negative 6. So this is a less than or equal to sign. And I prefer to rewrite it so that when I look at my graph, this kind of looks like an arrow, less than or equal to, and as long as you have your inequality statement written with your variable on the left-hand side, then this looks like an arrow. So if the arrow looks like it's pointing to the left, then I shade to the left. So find negative 6 on the number line. Because we see an or equal to, it's going to be a closed circle. So I have a closed circle at negative 6. And then because my variable's on the left-hand side, this looks like an arrow, and anything less than it would be shaded to the left. You do need to write the inequality statement, write your answer, as well as graph it on a number line. All right, let's look at example 6. So in example 6, right away I see I have a number times parentheses. Hopefully that's looking familiar. I have negative 9 times a plus 6 in parentheses greater than negative 45. I really hope that's looking familiar to you. Anytime we have a number times parentheses, we have to do that distributive property, meaning I have to distribute the negative 9 to both terms inside parentheses. So negative 9 times a gives me negative 9a. Negative 9 times 6 gives me negative 54, and it's greater than negative 45. I'm trying to get a by itself, so I need to move constants to be on the same side. So the way that I move a negative 54 to the other side is by adding 54. So I'll do plus 54 on both sides. And I'm left with negative 9a is greater than negative 45 plus 54 gives me a positive 9. Now I almost have a by itself, but the last step here, I have to divide by a negative 9. Ooh, and make a note. We just did a divide by negative, so I'd make a note here, make a star, flip. I need to flip this inequality sign. So it was a greater than, it's going to flip to a less than. So on this side, when I divided, I'm left with a. I flip my inequality sign. It flipped from a greater than to a less than sign. And then on the right-hand side, 9 divided by negative 9 gives me negative 1. So the inequality statement that I'm graphing here is a less than negative 1. So find negative 1 on your number line. It's a less than sign, so it should be an open circle. And less than means everything's shaded to the left. Make sure you're putting an arrow on it again. And because my A is on the left-hand side, because this looks like an arrow looking or shading to the left, you can just go ahead and shade to the left. All right, example 7. I'm going to take a moment, rewrite this. 4 plus 6n less than 4n plus 4 plus 7n. And the left side of my inequality sign will stay the same, 4 plus 6n. However, on the right side, I can combine like terms. Remember, you can always combine like terms on the same side. So I have 4n and 7n. Those are both variable terms. I can combine those to be 11n plus 4. Now we want to start moving our variables to one side and constants to one side. I'm going to move my variables to the left because at the end, I like my variable to be on the left of my inequality sign. You can choose to move your variables to the right. You'll get the same answer, but I'm going to do minus 11n so that I can move my variables over to the left. So now on this side, I have 4, 6n minus 11n gives me negative 5n, and I'm left with a 4 over here. So now I need to get my constants on the same side. If I want to move this positive 4 over to the other side, I need to subtract 4 from both sides. So now I have negative 5n is less than 4 minus 4 is 0. The very last step here, divide by negative 5. I'm running out of room. And make a note. What did I just do? Divide by negative 5. Put a star or write the word flip. I need to flip my inequality sign. So it's going from a less than sign to a greater than sign. So here I'm left, on this side I'm left with n. I'm flipping from less than to greater than. Again, the reason we flip our inequality sign is because we divided by a negative number here. We divided by negative 5, so I flip my inequality sign from less than to greater than, and greater than 0 divided by anything is 0. So this one is n greater than 0. So now go to your number line. I need to put an open circle at 0, and it's greater than, so anything shaded to the right. Last example, example 8. Take a moment, rewrite it. 8k minus 35 is less than 8. Ooh, and I see I have 8 times some stuff inside parentheses. So right away, that's an indication to you 8 times parentheses means we're going to have to do distributive property. So my left side stays the same. 8k minus 35 is less than 8 times k. It's 8k. 8 times 4, don't forget to distribute the 8 to the second term. 8 times 4 is 32. Bring down your plus 6. Let's see. My left side will stay the same, 8k minus 35. But here I can combine 32 plus 6. Those are constant terms, so I can combine those. So I'll still have the 8k, which is the variable term. 32 plus 6 gives me 38. All right, so now I cannot combine like terms on the same side anymore. Now I need to start moving some stuff. So I'm going to move my variables to the left. So to move a positive 8k, I need to subtract 8k from both sides. Ooh, and I see something is happening here. When I go to subtract 8k from both sides, 8k minus 8k drops out, and I'm left with 38 on this side. 8k minus 8k drops out, and I'm left with negative 35 on this side. So my k's dropped out of the problem, and this is one of our special cases. This is an inequality statement, and you have to decide if it's true or false. So negative 35 is less than 38. That would be true. So then if you have a true inequality statement, then your answer is all real numbers. All real numbers. And this is what you should be boxing or circling as your final answer. This is not your answer. This is your work. True is not your answer either. Your answer is all real numbers. Okay, so here's our answer, but don't forget about the number line. If all real numbers or any number works, what should be shaded on the number line? Every possible number, right? So you're going to draw a line with arrows on both ends. Any number on this number line extending far off this number line, positive direction, negative direction, it works. So all real numbers with a line going in both directions on the number line. That would be your solution. All right, please pause the video and give these 4 U-tries your best effort. We did on the first U-try, we ended up dividing by a -1. So I made a note, we had to flip our inequality sign. So it flipped from greater than or equal to less than or equal to. So our answer, the inequality statement should be x is less than or equal to 5. We should have a closed circle on 5 with an arrow shaded to the left. Our second U-try was tricky because you need to remember what we learned with solving equations. So this 9 plus n in the top of the fraction is trapped up there. That was part of our PEMDAS, order of operations. We said with the parentheses, the P for PEMDAS, P for parentheses, also includes the top and bottom of fractions. So 9 plus n is trapped in the top. I put parentheses around it to remind myself of that. I first have to undo this divide by -3. And I undo that by multiplying by -3 on both sides. Then I can finally get to the 9 plus n. And right here I multiplied by -3. So I always like to make a note. I put a star and I wrote flip because I had to flip my inequality sign from greater than to less than. My inequality statement reads n is less than -3. So I should have an open circle at -3 with an arrow shaded to the left. The third U-try, something interesting happened when I went to combine like terms up here, and then I went to go move my m's to the same side, and I subtracted 3m from both sides. It canceled on both sides, dropped out of the problem. So I was left with 2 is less than or equal to -3. That's definitely false. There's no way 2 is ever less than or equal to -3. If it is false, then our answer is no solution. And we didn't talk about this, but if there's no solution or no answer, what do you think goes on your number line? Nothing, right? No answer, so I should see no marks on your number line. It's just a blank number line. The very last U-try here, we had to do the distributive property, and then this one did also involve a flip of the inequality sign. I get to this point and I divided by -20, so I made sure to make a note that I flipped my inequality sign and it flipped from less than to greater than. When you go to graph on your number line, be very careful. You are reading from the variable. So this reads n is less than -4. Don't look at this inequality sign and assume that this is greater than, so you're going to shade to the right. You read from the variable. So I like to rewrite it with variable on the left. That's the safe way to go. Variable on the left would be n is less than -4. So I have an open circle at -4 and shaded to the left. Please let me know what questions you have.